First of all, let us remember that we have done multiplication of matrices, we have done addition of matrices, equality of matrices, subtraction of matrices. So if we see a question from this portion, multiplication of matrices, as we all know, is about row to column matrix multiplication like this. We take a row, element of a row, A1, A2, A3, suppose here, B1, B2, B3. I hope you remember this, na? Should I tell you this or you remember this? Multiplication of matrix, you know. I hope so because you have recently given the exam. So I'm just giving you an idea that what we used to do, we take this row and this column and we multiply them like A1, D1 plus A2, E1 plus A3, F1. And that would become the first element here. Then we will take the first row and the second column, and then we will multiply them like this, and we'll get this element. Then we'll take the first row and the third column, and we get an element here. Similarly, second row if we take, and the first column, and we multiply like B1, D1 plus B2, E1 plus B3, F1, we get an element here. So this is how we used to do multiplication of matrices, and we can fill other places in the similar manner. If we do addition of matrices, then what we used to do, the conformable matrices, that it is M cross N, this is also M cross N. And then we used to add this element with this element, this element with this element, likewise. Okay, so conformable for addition. And what was the conformable for multiplication? It was like, it is M cross N. If it is, then it has to be N cross P. The resultant will be M cross P. So this was a concept, multiplication of matrices, and then addition of matrices, equality of matrices, subtraction of matrices, all these things. So there have been questions which were asked in previous years based on these concepts. So let us see any one question from that. So I'm taking one question and I'm elaborating this one. It says, it is 2021, in JEE 2021, this question has been asked. And it says that let A is a matrix which is having elements 1, 0, 0. So this is 1, 0, 0, and then 0, 1, 1, and then 1, 0, 0. And then it is being asked that then A to the power 2025 minus A to the power 2020 is equal to, A option is given, A to the power 6 minus A. B option is given, A to the power 5. C option is given, A to the power 5 minus A. And D option is given, A to the power 6. Now it is being asked that which one option is correct among these. So here, in such type of questions where index is very high, like 2025, 2020, these are very high index. So in such cases, we have to understand that we have to see the pattern. The important thing is the pattern here. So how do we see the pattern? So we have to multiply it few times. Like we have A here and we want to find A square. So we multiply this A with A and we will get A square. And multiplication is, we have already seen what is multiplication of matrices. So first row with the first column, when you will multiply, you will get 1, because 1 into 1, 0 into 0, 0 into 1. So overall will be 1. You will take first row and second column, you will get 0. We'll take first row, third column. So you will get 0 again. Second row and the first column you will take. So it will be 1. Then second row, second column, then it will be 0 plus 1 plus 0, that will be 1. Then second row, third column will be 0, 1, 0. So it will be 1. Then third row, first column, I think you are following me. 1 plus 0 plus 0, 1. If you have any doubt in any step, you can just ask me. 0 plus 0 plus 0, that will be 0. And then it will be 0 plus 0 plus 0, that will be 0 again. So this is a square. Now let us do one more thing, find a cube also. So we have to be able to understand what is the pattern. So 1 0 0 0 1 1 1 0 0, this is a, and a square is 1 0 0 1 1 1 and 1 0 0, which we have just obtained. So if you multiply this a with this a square, what will you get is, this would become again 1 here, then it will be 0, then it will be again 0, and there you will get 2. This is important here. Now we are seeing some pattern. So what it is, second row with the first column when we are doing. So 0 plus 1 plus 1 is 2. Then we are getting 1. Then we are again getting 1. Then we are getting 1 again. Then we are getting 0. And then we are getting 0. So this is a cube. Now if you see the pattern here, if you just try to understand the pattern, what is happening over here is, that if we see this, that a is 1 0 0 0 1 1 1 0 0, and a square which we obtained is one second. Yeah. So a square which we obtained is 1 1 1 0 0 1 1 0 0, and a cube which we obtained is 1 0 0 2 1 2 1 1, this is 1 here, and 1 0 0. So based on this pattern, if someone asks you that what will be a to the power 4, so can any one of you tell me what will be a to the power 4? And also tell me the name, whoever will respond.
Second row, first column will be 3.
Second row, first column will be 3, correct. So based on the pattern, we can say, so this was Adrian. You have responded, no?
Yes, sir.
Okay. So based on this pattern, we can say it is 1 0 0 3 1 1 and 1 0 0. If we talk about a to the power 5, the value here will be 4. If a to the power 6, the value here will be 5. Rest will be same. So a to the power n is this thing. This is a to the power n in general. Now it was asked a to the power 2025 minus a to the power 2020. So a to the power 2025 minus a to the power 2020, if you want to find, it will be 1 0 0, and this will be 2024 1 1 and 1 0 0. If you talk about 2020, it will be 1 0 0, 2019 1 1 and 1 0 0. Now this would become 0 0 0 5 0 0 0, 0, 0. So this is the value which we are getting. This is subtraction of matrices. First we did multiplication of matrices. We saw the pattern and then we did subtraction of matrices. So the corresponding terms get subtracted. Now after seeing this, you have to see which option is the correct option. So you have many options. Like if you see here, a to the power 5 and a to the power 6 you can't take. Because a to the power 5 means this will be 1, 4, 1, 0, 1, 0, 0, 1, 0. A to the power 6 will be 1, 5, 1, 0, 1, 0, 0, 1, 0. So these are not the values. Clearly, this a to the power 2025 minus a to the power 20 is not this value, because here everything is 0 except this term, which is 5. Now, if you see again option A and option C, so option A is a to the power 6 minus a. So if you find a to the power 6 minus a, as we see here, a to the power 6 is this. This is 1, 0, 0, 5, 1, 1, and 1, 0, 0. And this was a to the power 6 minus a. And a was, if you remember, and you can just see from the general formula also, 1, 0, 1, and 0, 1, 0, 0, 1, 0 it will be. So you will get, after subtraction, 0, 0, 0, 5, 0, 0, and 0, 0, 0. So this is actually a to the power 6 minus a, which is same as a to the power 2025 minus a to the power 2020. Both are same. So you say that A option is correct, and also C option will not be correct, because a to the power 5 minus a will give you 4 at that place, not 5. So this will be the correct option. So I hope it is clear to everyone. If it is being asked or a similar question will be asked, you will be able to do multiplication, seeing the pattern, subtraction, all those things. Some students
Yes,
have
sir.
joined a little later. Okay, Priya, Hamza and Prajwal, you have joined little late. So have you understood this?
Yes, sir.
Okay. What about Prajwal? Have you understood it? Okay, you have messaged on the chat. Fine. So now what we see here is, I would like to give a question to you on the similar pattern. And this question is basically asked in again 2021 in shift 2, 25 July. So here you have to also do matrix multiplication and see the pattern. So I'll give you few moments, like 2-4 minutes. So you will be able to attempt it. These are the options here. So I would suggest first try it, then we'll discuss it. And if you will have a doubt at any point, you can just ask me. I'm here only and I'm just here to help you out. Priyadarshini has given the answer and her answer is right. I won't tell the answer right now, but so that others will also try it out. Adgil has also given the correct answer. So should we discuss it now or others are trying?
Trying, sir.
I couldn't hear. It was very low voice. Who said? Should we discuss? One more answer has come. Krishna Vamsi, correct answer. Okay, now let us discuss it. So here, okay, one more answer has come from Hamza. So that is also correct. So P square is 1 0 half 1 multiplied with 1 0 half 1. So this will become 1 0. This will become 1. Half plus half will be 1 and 1. One more step, let us do P cube. So 1 0 half 1 1 1 0 1. So this will become 1 0 3 by 2 1. So this is PQ. So seeing on the pattern, we can say that P2 is like this 1 0 2 by 2 1. P cube is 1 0 3 by 2 1. So P4 will be of course 1 0 4 by 2 1. So in this pattern, Pn is equal to 1 0 n by 2 1. So if we talk about P to the power 50, so 50 by 2, that is 25. So option is A. That is fine. Now, some questions have also been asked sometimes about the counting. You may see few questions on counting. So let me give you a question and then we'll discuss it. Hmm. There is one question here, but let me give you first an average question so that you would be able to understand the concept. Okay. So here there is one question. This is not an average question. It is a good question, but still we can discuss it. The number of elements in the set. The number. This is a question which has come in 2021 JEE in August shift 2. The number of elements in the set A equal to A, B, 0, D, such that A, B, and D belongs to -1, 0, and 1, right? And I minus A cube. So this is basically algebra of matrix also involved here. So I minus A cube equal to I minus A cube like this. Okay, not whole cube, but like this. Where I is a 2 cross 2 identity matrix. So first of all, we have to see here that there is this relation. This relation we have to solve. So this is related to algebra of matrices. So here algebra of matrices is same as we study the real matrices of algebra of real numbers. So this is same as algebra of real numbers. That is, what is the formula in A real numbers? That A minus B whole cube is equal to A cube minus B cube minus 3A square B plus 3AB square. In similar way, if we take I minus A whole cube, so it would become I cube minus A cube minus 3I square A plus 3IA square. So this would become identity matrix. How many times you multiply it, it doesn't matter. It will be identity minus A cube. Here identity is multiplied twice, then it is identity, and multiplied to A, then it will be A matrix only. Identity matrix is multiplied with any matrix will give you the same matrix. So this is what we have. Now this is given as I minus A cube. So this term is given as I minus A cube. So what we do, we cancel I minus A cube from both the sides, and we get 3A square minus 3A equal to 0, which implies that A square minus A equal to 0, which implies that A square equal to A. Now here there is a term which is being given such type of matrices. Can anyone tell me what is the name of such type of matrices, where the square of the matrix is same as the matrix? Such matrices are called idempotent matrices, right? These matrices are called idempotent matrices. So A square equal to A, then it is an idempotent matrix. Now, what was A? AB 0D. It was AB 0D. So A when multiplied with the same AB 0D, it will be AB 0D. So A square equal to A means this, which means that A square and AB plus BD, then 0 here. So again, we are doing matrix multiplication, and D square. This is equal to AB 0D. So this is what we have. Now from here, if you have any doubt in any step, you can surely ask me. So this A square is equal to A. A square and A is same. D square is equal to D. And 0 is of course equal to 0. We don't have to do anything here. And AB plus BD is equal to B. So let us take B common here. So B into A plus D is equal to B. This is what we can say. Now for this to be an idempotent matrices, all of these should be true. So if all of these are true, then from here what we get? That a square minus a equal to 0, or we say that a into a minus 1 equal to 0, which means a equal to 0 or a equal to 1. Similarly, d square equal to d, you will solve with the similar manner and you will get d equal to 0 or d is equal to 1. And here when you will solve it, you will get either b equal to 0, because you will of course take it on the left side, and it will be b into a plus d minus 1 equal to 0. So either b equal to 0 or a plus d is equal to 1. That is a plus d minus 1 equal to 0. Now all of these are to be true. So what are the possibilities here? If we take these two possibilities, so a could be 0 and d could be 0, a d values. It could be 0 1, 1 0 or 1 1, like this. Now what are the values of b? So b is 0. So if we take b 0 in all these cases, so 4 cases are coming. 4 cases here. Now can we get similarly cases in another one also? So a plus d equal to 1. So when is a plus d1 possible? If we take a0 and d1, then it is possible a0 d1 or a1 d0. So a1 d0. So in both the cases, a plus d is equal to 1 is possible. So a0 d1 or d1 d0 a1. What will be b? Can you tell about b? So basically, b, we have independence of choosing, because as we have here above in the question, a, b and d actually belongs to -1 0 and 1. So here there is, in another case, we can take b as -1 or 0 or 1. These options are there. But if you see, if you observe, this taking 0 does not make any sense. Why it does not make any sense? Because 0 1 0 we have already covered here, and 1 0 0 that also we have covered here. So that we can not again repeat, because it is just a repetition. So the case would be 0 1 minus 1, 0 1 1, 1 0 minus 1, and 1 0 1. So there are the 4 cases here, and the 4 cases there. So 4 cases plus 4 cases, overall you will have 8 cases. Is it okay? Are you getting this? If you have doubt in any step, you can ask, because such type of counting questions have been asked few times in JEE in the previous years. And sometimes it is a good question. It is a little difficult question. It is not always that such difficult question is being asked. Sometimes average question is also being asked. But you have to understand that how the cases are being made in such situations. There is, I remember one counting situation also in NCRT. There is a question, there was how many number of matrices can be formed if the entry is 0 1. So that was a simple case. So you can just write it this one, and then we can proceed to next one. Anyone having doubt in this? Okay, just write this end portion at least, the final result, or I'll be back in 2 minutes. Just write this down. Okay. So now we come to anyone not having any doubt. You have understood the cases. It is little time taking, but you can do such questions. So it is not that these are very, very difficult. If you have understood and have practice, then you will be able to do this. Okay, before coming to any question, I'll just remind you about symmetric and skew symmetric matrices. What were symmetric matrices and skew symmetric matrices? So symmetric matrix is a matrix. If you take its transpose, it is equal to the matrix. And if you see its nature, it is something like this, that this is A, B, C, D, E, F. So here also D, E, F like this. So it will sort of symmetrical, that this portion and this portion would be symmetrical about the diagonal. And what about skew symmetric matrix? If you take the transpose, it is minus of A. So here what happens, that diagonal elements are all zero. This you have to remember, that in skew symmetric matrices, the diagonal elements are all zero. And non-diagonal elements are something like this. That is, you are taking it this as DEF. This will be minus D, minus E, minus F. Then if you will take the transpose, it will become equal to minus of A. So this is what we did in symmetric and skew symmetric matrices. And if we see a question based on them in the previous years, so we have few questions. So the question says, if A is a symmetric matrix, this is a question which has been asked in 2019 April. If A is a symmetric matrix, and B is a skew symmetric matrix, such that A plus B is equal to sorry, there was a call. So A is a symmetric matrix and B is a skew symmetric matrix, and it has been said that A plus B is equal to 2, 3, 5 minus 1. Then AB is equal to, that is A multiplied with B is equal to minus 4. Options are given. I'm giving you the options. A option is B option is C option is and D option is so. Would you like to first attempt this question? Let me give you a hint. Just try this and then we'll discuss. Uh, what you can do is A plus B is given to us. Like find A plus B transpose. Okay. And use the fact that A transpose plus B transpose is A plus B transpose. This is a property which you can use. So taking the transpose of A plus B is not a big task. A plus B transpose, if you will take, it will become transpose of this. That means 2, 5, 3, -1. You are taking the transpose of that matrix A plus B. Now that is equal to A transpose plus B transpose. This is the property. This is what the property says, that A plus B transpose is same as A transpose plus B transpose. Now you have to use the fact that A is symmetric. So if A is symmetric, what should we write A transpose as?
A.
What will be A
A.
transpose if A is symmetric? We have just discussed this above.
A.
Yes. We will write it as A. And is so B transpose will be
So minus B.
minus B, correct. So we have this as A minus B. Now what we have got here, just see that A minus B is equal to 2, 3, 5 minus 1. So we have got two equations and two unknown. One equation is this one, A plus B is equal to this. Another equation is this one, A minus B equal to this. We will add them, B will cancel, and 2A we will get. From there, A we will get. Similarly, we subtract and A will cancel, we will get 2B. From there, we get B. And when we get A and B, we multiply them and we get the result. So can you do this part right now? Have you understood now what we have to do? Solving two equations and two unknowns. A and B are two unknown matrices. Just as we do operations or real numbers, here we have to similarly do algebra of matrices. So I'll giving you 2-4 minutes, just find it out. So when you will add them, what you will get is, I hope you have done this also, but still, let me give you the result. And you will add this, 2a will be equal to, you will add the corresponding elements, 2 plus 2, that would be 4, 3 plus 5, that will be 8, 5 plus 3, that will be 8, minus 1 minus 2, and then you will divide by 2. So division by scalar. So all the elements will be divided by 2. So this will become 2, 4, 4 minus 1. And you will divide by 2, this on the right hand side. So all the elements will be divided by 2. B, Krishna Vamsi is saying, and B is the correct answer. Good. Similarly, when you subtract, you will get the matrix B, and then you will multiply A with B, you will get the correct answer. Okay. So this part, everyone will you do. This is just calculation part, so I'm not going into too much of it right now. Main thing you have understood. And if you have any doubt, you can surely ask me. Now, let us see some question based on assertion reason. There is uh, a question of assertion reason which has been asked in 2011 of symmetric and skew symmetric. So I will ask it in a different manner. I am not asking it as the assertion reason. I'm just asking as a true false. So you will have to just tell me whether this statement 1 is true or false. Similarly, a statement 2 is true or false. Because if you can give that answer, you can solve that question. So ABA and ABA are symmetric matrices. It is saying that ABA and ABA are symmetric matrices. So first thing, let me tell you that matrix multiplication is associative. What it means associative? That means that if you do ABC like this, or you do ABC like this, both are same. So if you can tell whether it is true or false for this one, it will be applicable here also. So you don't have to do for them differently. So just tell me whether this one is a symmetric matrix or not. And it is given that A and B, of course, unless it is not given, we won't be able to do. A is symmetric matrix and B is symmetric matrix. This is given to us. And then it is being asked that whether this matrix is symmetric or not. So can you tell me it is true or false? Meanwhile, let me tell you one property also which will be used here. It is a very, very important property that if you multiply two matrices and you take the transpose, it is equal to taking the transpose and multiplying in the reverse order. This is a very, very important property. Just remember this, that A into B transpose is B transpose into A transpose. It is not A transpose into B transpose. So someone has given the answer. Krishna is saying a statement 1 is true. Hamza is saying false. Priyadarshini is saying true. Okay, 3 people have given the answer. 2 have said it is true. 1 has said it is false. So it is a true statement. How it is true? Let us see. So if you see here that A, B, A, they are talking about A, B, A, like this. So if it is symmetric, then what should be there? That if you take the transpose of this one, this should be equal to the, here you have to understand that these two are the matrices. Sorry, uh, this whole is a single matrix, so it should be A, B, A. Then it will mean that it is symmetric. A matrix, its transpose is equal to the matrix, then it is called symmetric. Now we have to show this if it is true. If it is false, then it will not come so. So from here we'll say B A transpose into A transpose. We'll use this property that if two matrices, this is one matrix, this is another matrix, order will change. BA will come first, A will come second. And then when we take BA and we take its transpose, it will be A transpose, B transpose into A transpose. So again, this order BA will change into AB. And then since A and B are symmetric, so A transpose can be written as A, B transpose can be written as B, and A transpose can be written as A. Now it is associative, so you can put the bracket here also. So you get this. So finally you got that it is symmetric. Anyone having any issue? So this fact is given to us that A and B are symmetric. Then only it is being asked. This is given. Then only in this step you can write A transpose as A, B transpose as B, and A transpose as A. I hope it is clear. Can we come to statement 2? Okay, so I am coming to statement 2. It says statement 2 is saying that AB is symmetric matrix if A, if matrix multiplication of A with B is commutative. In short, if AB is equal to BA. Commutative means AB is equal to BA. Multiplication is commutative means this. So in general, AB is not equal to BA. Okay, this you remember. In general, it is not. But in some cases, it may be possible. So here it is saying that AB is symmetric matrix if AB equal to BA. Is this a true statement or not? Not always, Priyadarshini is saying. Like Priyadarshini, it is not always true if it is not commutative. But if it is commutative, then it will be true now. Ideal is saying true. So here you should not get confused that because it is saying now AB is symmetric matrix. AB is a symmetric matrix. So AB is asymmetric or not, we don't know. We have to find out. So we find AB transpose, it will become B transpose into A transpose. And then we can write B transpose as B, A transpose as A, because it is B and A are symmetric given to us. It is given that B transpose is equal to B, A transpose is equal to A. So this is how we write it. Now this BA is actually equal to AB, right? BA is equal to AB because this is commutative, as it is said above that if AB is equal to BA. If this condition was not given, then we could not have written it like this. Now, finally, AB transpose is coming equal to AB. So we can say that AB is symmetric. So if it is commutative under multiplication, then it is symmetric. If it is not commutative, which is in general possible, so it is, you will say it is not always symmetric. So that is right, but here something was given. So based on that, we can say that it is symmetric. Is it okay, Priyadarshini?
Yes.
Others also it is clear?
Yes, sir.
Yes.
Okay, Krishna and Hamza. So now we will discuss few things based on a concept. Let us see. Yeah, there is one thing which is called adjoint. If you remember adjoint of a matrix, will next class we'll see determinants also, but little bit knowledge of determinant you have basically. So adjoint of a matrix is actually cofactor of the matrix A transpose. This is the adjoint of a matrix. Like you have a matrix A11, A12, A13, A21, A22, A23, A31, A32, A33. And you have been asked what is its adjoint. So adjoint will be, you will take their cofactors. So cofactor of A11 in generally written as C11. How we take cofactor? You remember, we eliminate that row and column, and from the remaining we do the cross multiplication, and we also put a plus minus sign depending ki its position or is even or odd. So it is plus here because 1 plus 1 is even. If you take A12, it will be minus there, and you will eliminate this row and this column, and you will take these values. So this is how we used to find cofactors, right? And if you take the cofactors and then transpose it, then you will get adjoint of a matrix. So there is one important relation that determinant of adjoint of a matrix is actually determinant of the matrix to the power n minus 1. This is a very important relation, and many times questions have been asked from this concept. What is n here? N is the order of the matrix. If it is 2 cross 2, then it will be 2. If it is 3 cross 3, then it will be 3. So n is the order of the matrix. So based on this concept and this fact, if we see a question here, it says if P is equal to one alpha 3, 1 3 3, 2 4 4 is the adjoint of a 3 cross 3 matrix A. and determinant of A is equal to 4. Then alpha is equal to, options are given, 4, 11, 5, 0. Just try this using this fact. So P is adjoint of A, right? So you will find the determinant of P, that will the determinant of adjoint of A, and from there you will proceed. Priyadarshini is saying the value is 4. Priyadarshini, I think you have not got the correct answer. Krishna is also saying, no, Krishna is saying option B, which is 11. That is fine, Krishna. So it won't take much of the time to calculate it. If you see the above thing to do, that adjoint of A determinant. So you take the determinant of this. So it will be 1 and 3 into 4 minus 3 into 4. Then you will take minus alpha, and then 1 into 4 minus 2 into 3. Then plus 3, and then 1 into 4 minus 3 into 2. So it will become 12 minus 12 cancel. It will become 4 minus 6 minus 2. So 2 alpha it will become. And 4 minus 6 it will become minus 2, and minus 6 it will become. So 2 alpha minus 6. So if you see here that 2 alpha minus 6 is determinant of adjoint of A. Now what is the determinant of adjoint of A? If determinant of A is 4, can anyone tell me?
4 square.
4 square, correct. Who has said?
Krishna.
Okay. So 4 square it is correct, because we know that adjoint of A determinant is determinant of A to the power n minus 1, and n is the order of the matrix, which is 3. So it will be 3 minus 1, 2. So 4 square it will be 4 to the power 3 minus 1, which is 4 square, which will become 16. So 2 alpha will be equal to 16 plus 6, which is 22, and alpha will be equal to 11. So alpha is equal to 11 is basically our answer, which is option number B. Similarly, we will see a question on transpose right now. So this question is being asked in 2015 JEE. Since we have just seen what a transpose is, and we also know matrix multiplication, we can do this question. If A equal to 1, 2, 2, 2, 1 minus 2, A, 2, B is a matrix satisfying the equation A into A transpose is equal to 9I, where I is the identity matrix. Then you have to find the value of A as well as the value of B. So here you can see what is given, A is given, and you can find its transpose also, interchanging row and column. That is what we do in transpose. So find its transpose and multiply them, A and A transpose, and equate it to 9I. 9I will be basically identity matrix multiplied with 9. So it would be something like this. So just try it once and then try to find the value of A and B. Matrix multiplication is very important because you see that in all types of concepts, whether it is question on adjoint, transpose, solution of matrix equations, you will see that there is somehow involvement of matrix multiplication. So you have to be well equipped, or you can say that you should practice matrix multiplication as much as possible so that there won't be any error. And this is a part where if you will do a small mistake, there will be the error. Like here, if you see that you are taking the matrix 1, 2, 2, 2, 1 minus 2 and A, 2, B, and you multiply it with a matrix which is its transpose 1, 2, A, 2, 1, 2, 2 minus 2B. So this is A into A transpose. Now you have to do the multiplication. You can't skip that. So when you will multiply this, so some of the things you should try to do mentally. So that won't let you write down everything. So 1 into 1 is 1, 2 into 2 is 4, 2 into 2 is 4. So final value will be 9. Okay, A is -2 and B is -1. Krishna is saying A is -2 and B is -1. Let us check. Yeah, correct. Good. So if you do the multiplication, this will be 9. Another will be 2. 2 minus 4, that will be 0. Next would be a plus 4 plus 2b. So a plus 2b plus 4 you will write. Then it would be 2 plus 2 minus 4, 0. Then it would be 4 plus 1 plus 4, 9. Then it would be 2a plus 2 minus 2b. Okay. 2a plus 2 minus 2b. Fine. Then we have a plus 4 plus 2b. Then we have 2a plus 2 minus 2b. And then we have a square plus 4 plus b square. This is what we are getting. A square plus 4 plus b square. Now this is equal to 999,000,000,000,000,99. That is what was given. So if you see equality of matrix, you will equate all the corresponding elements. Someone has also given the answer b minus 1, a minus 2 by Adriel. Yes, Adriel, correct. So if you see here, so this 9 is equal to 9, this 0 is equal to 0, this 0 is equal to 0, this 9 is equal to 9. And then a plus 2b plus 4 equal to 0. And 2a plus 2 minus 2b is 0. So you can take 2 common and write it as a plus 1 minus b as 0. This will be 0, this will be 0. So these are the same thing as this one. And a square plus b square plus 4 is equal to 9. So a square plus b square is equal to 5. So now if you solve these two, so subtract them and you will get 2b plus b 3b, and 4 minus 1 3 is equal to 0. So b will be minus 1, and when you took b is equal to minus 1, so a will be minus 2. But one last thing you need to do, because it may be possible that it may not satisfy the last equation. So you have to do that also. But here it is somehow satisfying it. So a square is minus 2 square, b square is minus 1 square. So it is 4 plus 1, 5, which is 2. So b is minus 1 and a is minus 2. This is our answer. So here not lot of trick was needed, and not lot of depth was needed. You just need to understand matrix multiplication, and you need to solve the equations into variables by equating the terms of the equal matrices, corresponding terms of the equal matrices. Now, one last question we will do, and then we will finish today's topic. This is again not a very difficult question. It is just a need of a little bit of calculation here. If a is equal to 2 minus 3 minus 4, 1, a is equal to 2 minus 3 minus 4, 1. Then you have to find adjoint of 3a square plus 12a. So you have to do matrix multiplication, then addition, then a scalar multiplication with a matrix, and then finding adjoint by finding the cofactors, and then take its transpose. So these basic calculations and results you should be clear, because if you get an average question, then it is expected that you must do it. If it is a difficult question, there is a chance you may not get click or you may get click. But if it is an average question, you must do it. Let me give you the option also, because you won't be able to write it on the chat. So the options here is 72 minus 84 minus 63, 72 minus 84 minus 63, and 51. The option is 51, 63, 84, 72. The option is 51, 84, 63, 72. And D option is none. Krishna has said B option, which is correct. So let us do the calculation part. Krishna, you are doing fine, so keep it up. And also in other topics. Ideal, no, it is not none. Priyadarshini, correct, it is B. So if you see here, A square, let us find A square. So A square will be multiplication of A with A. So what will you get is 4 and 12, 16, and minus 6 minus 3 minus 9, and minus 8 minus 4 minus 12, and 12 plus 1, 13. So this is A square. And then they are saying 3A square plus 12A. So 3A square plus 12A, if you will find, you will multiply this with 3, this will be 48. This will be minus 27. This will be minus 36. And this will be 39. And 12A that you will multiply with A, so it will become 24 minus 36 minus 48 and 12. And then you will add them, you will get 72, and you will get minus 63, right? And then you will get 48 and 76 will be 84. It will be minus 84, and 39 and 12 will be 51, right? Now this is 3a square plus 12a. You have to find its adjoint. So what we do in adjoint, we take the cofactors and they take the transpose. So cofactor will be 51 here, and here it will be 84 because this it is a odd position, first row, second column, and this will be 63 and this will be 72. And now we will take the transpose. So it will be 51, 63, 84, 72. So 51, 63, 84, 72. Yeah. So option B is the correct option. So this is how we find it out. So here we are finding the adjoint of 3a square plus 12a. So I hope the maximum type of questions and different topics we have covered in matrices. Some of the things are there in determinants also. So like simultaneous equations, solution, and Kramer's rule and these things. So we'll see that also, and properties of determinant. That is also important. We'll see that in determinants. So that will be the determinant part. So I hope you found this class fruitful, and keep regular, keep coming in the class. It is very important. And don't miss any class till your JEE mains exam. It has been especially designed for your need. So please try to understand each and every concept which is being discussed. Try to revise them, try to do practice more questions. And the most important thing is to ask doubts. If you have any doubt, anything, you should ask in the class. Don't be shy. Don't think that others is not asking, so why should I ask? I will be little embarrassed to ask. Don't think that. Any type of doubt you need to ask, you have to ask. So don't be shy and always take maximum benefit from the class. That is what I would like to say, and interact more in the class, ask questions. So thank you for today. Thank you, everyone.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you.